Hi, this is John Avina. I'm here with Mark Stetz. He's wandering around, but he'll show up in a second. Oh, here he goes. Mark is one of my favorite Sagir Sharmuters. We're we're here in Riyadh, Saudi Arabia right now, actually. We're on separate trips for separate purposes, but actually end up meeting here to do this webinar for you. Anyway, I'm not going to tell you much about Mark's history because he didn't give me a bio. He'll do it himself. And Mark's going to go through this slideshow or presentation that he put together, and I'll probably interject because that's what I do. So go ahead, Mark. Tell him about yourself.
Assalamu alaikum. Well, Sabah al-Khair from Riyadh, Saudi Arabia. Anyway, just wanted to talk a little bit about what evaluators do and why you should care. So our agenda, talk a little bit about the background of performance contracting, risks, how to allocate, mitigate those risks, how M&V ties into that, and then finally what PFs and evaluators look for, summary, and then we'll have some discussion. So slide. So just why I might know a little bit about what I'm talking about, but I've been around this field for, I don't know, going on 25 years now, so I've earned that gray hair. But, you know, I've been supporting or have supported the DOE's program probably since 1999, 2000 timeframe. And among other things, I worked as a project facilitator for some of the major departments and large projects that have been implemented under the ESPC program. And also got my start writing and contributing to the FEMP M&V guidelines like 2.2 and 3.0 and all those other guidance documents. I've also dabbled with IPMVP, and I teach workshops to ESCOs to kind of show them how to do this stuff. Taught the first CMVP class in China and Jordan. And I'm here in Saudi Arabia working with what we call a super ESCO, who goes by the name of Tarshid. Tarshid is Arabic for efficiency. And a lot of their program, some of it is modeled on ESPC, but there's some similarities and there's also some differences. Anyway, slide. All right, so performance contracting. So I'm assuming that most people here are either an ESCO, work with ESCOs, or possibly hire ESCOs, but I'm going to be speaking from the perspective of ESCOs primarily. So just to reiterate, I think we know this, maybe some of the younger folks are maybe not quite clear on this point, but we know that the performance contracting is a model where the ESCO is promising performance, really. It's not that you're not selling lights, you're not selling HVAC, you're selling performance, energy and cost savings, you know, both now and 20 years from now. The problem, the challenge is that you're developing those proposals based on whatever information you can find today. And John was just complaining about the challenges of working without blueprints and single line diagrams, trying to figure out how buildings are constructed and how they're operated. And with that, then you have to put together a firm fixed construction price on your contract, define your savings guarantees, and longer term, there's a lot of variables that might affect the performance of your project and ultimately your savings. So what could go wrong? Slide.
Yeah. Okay, you guys all know a lot can go wrong. Okay, keep going.
All right, Mr. Obvious Man here. So, but if we look at a performance contract and we look at some of the things that can go wrong in the performance, you know, I break it up into three parts in some kind of, you know, three-dimensional vector diagram: performance, financial, and usage. And so when we consider these factors, it helps us align our thinking. Slide, please. All right, so here we have the three-dimensional diagram I was talking about. You know, they're somewhat orthogonal, but they all contribute ultimately to the financial savings that are achieved or, inshallah, not achieved. And so this is what we're going to discuss, and this is what your job it is to identify and understand. Slide. All right. So let's consider, for example, the known knowns when you're developing a proposal. You know what you need to know. So you need to define your equipment performance, its efficiency, lumens, maybe not lumens output, but certainly input watts and operating hours, maybe chiller COP, operating hours of your air handler, etc. So you start out with doing your DFS and you capture all this information.
They don't call it DFS in America.
I'm sorry.
IGA.
IGA. The term here we use is DFS, Detailed Feasibility Study, the ASHRAE Level 3. We also know that in the long term, there are things that we know are going to change in a somewhat predictable fashion, but we can't predict them absolutely. And so we think of weather. We know what the long-term average weather is, but we can't predict what the actual weather is going to be in 2022, for example. Likewise, when we're dealing with any kind of facility, we have only the occupancy today, and we often make the assumption that the occupancy remains the same. But we know many facilities can go up or down over time, and that affects our energy use. So we take that into account when we establish the baseline. And the same with energy escalation. Are we going to assume that the rates today are the same? Well, we try and factor in some escalation, even though we know in some cases energy rates have gone down, especially in the natural gas market. And then lastly are the unknowns, those things that just come out of left field that can wreak havoc with our projects. So a site that changes mission or radical change to occupancy, building closures. You know, if you work at a VA hospital or military base, you know, they're always changing and building new buildings and tearing down other buildings. And BRAC is base realignment and closure. So when you shut down a military base or a portion of a military base, that too affects your savings. But we know things might happen, but we can't predict when or what they're going to be. And then, of course, any major catastrophes should probably be handled by your force majeure clause. Okay, slide please. John is chuckling at my picture there.
Yeah, well.
All right. So risk, allegation, and mitigation. So identifying risks is half the job. Forewarned is half an octopus. I'll let you do the math. So what we're trying to do is figure out where those risks are, what they are, and then how do we minimize them and allocate them equitably. And that's what we're after. Slide. So we need to identify those things, the current and the future risk factors. But we generally work under the position of the party responsible for that factor should also assume the risk associated with that. If we can't identify a responsible party, then the customer, the agency, assumes the risk. So one example of that is the weather. You know, neither the ESCO nor the agency controls the weather.
I'm confused. I'm sorry. So you're saying this is what's supposed to go in the M&V plan where they assign risks? Is that what you're saying?
Yeah, and it may not say risk accordingly. We don't often use that word, and sometimes people get a little skittish. But if you base your savings on actual weather in 2022, 2023, what happens if the weather is either too hot or too cold and drives the savings up and down outside your tolerance bands? That is a risk. We may not call it that, but it's something you have to think in mind. And this is why we often try and use normalized savings, normalized to TMY. We'll go into more detail on that.
Right.
But this is what I mean by risk, that there are factors that can change that affect the energy consumption and the dollar value of the savings, but we have to identify what they are and say how we're going to treat them. But we can do that, and if we want to be diplomatic, we don't often use the word risk, but the concept is what I'm trying to drive home, not the vocabulary. Slide. All right, so in general, if we think of the performance, so what are the performance aspects of it? Well, design and commissioning. If you're the ESCO, you get to pick the equipment, you get to install it, you get to commission it, and measure the initial performance. That's on the ESCO, because that is everything within your control. In some cases, you may need to anticipate performance degradation. But the question remains, what happens if that degradation is caused by O&M and you're not the one conducting the O&M? And that's why you see I have 2 bullet points there. That means that that's really a negotiated point, and it could go either way, depending on how you treat that in your O&M plan. On the other hand, the usage factors and the financial factors, you want to push back onto the customer because they own those anyway. They're not assuming any new risk. It's always been there. If you didn't do the project, they would still have all those risks. So they're already accepting what is already there. Why should you accept those? So this is why we have to be careful about how we define savings and the conditions under which we assess savings. But you'll also see that I have an O&M cost assigned to both, because again, that becomes kind of a shared responsibility or a negotiated point, and it ties back into the first point under performance. So slide. So here in M&V, in a guaranteed savings arrangement, you need to show that you need to demonstrate conclusively that you've met your performance targets every year. your M&V report is your invoice. So just keep that in mind. And working with your customer, educating the customer is critical. It is essential. This is why I used to teach the M&V portion of the workshop to the ESPC customers back when I was supporting the DOE side of the project, because they need to know how this works and they need to be just as knowledgeable as you. What your customer doesn't know can hurt you. So I'm going to digress here. Back in the day, it was like 99, 2000, there was a ESPC, one of the early ESPC projects, and this was National Park Service, Ellis Island, you know, in the middle of the New York Harbor underneath the Statue of Liberty. And I think it was EUA Cogenics, don't quote me on that. And they had done a lighting and HVAC upgrade, you know, and even then they had a remote monitoring capability. So they could go in, you know, use AOL and a dial-up modem and get into the system and see that the lights were on or off and what the air handler status was. But they got rather upset when their monthly electricity consumption started going up. And so we had to send an engineer, and she went out, walked the facility, and discovered that they have a brand new, nice addition to the visitor center running on the same meter. And she tried to explain to them, you're using more electricity because you have a new facility running on that meter. And we had to write up a many-page report and educate them as to why you can't look at the utility meter. The ESCO had all the information. They had a defined baseline. They were doing an option A, option B approach, I think mostly option B, and their part of the project was working fine, but the customer was complaining because they didn't understand that doubling the size of the facility doubled the energy use. And so they were blaming the increase on the ESCO doing something wrong, not that they had built a nice new visitor center. It is nice, I've seen it. So.
Who won in the end?
Ultimately, the ESCO prevailed, and we eventually convinced the customer that, yes, the visitor center is what's using all the electricity.
Were you part of the ESCO, or are you a consultant?
I was working with the DOE at the time.
Okay.
Although I personally didn't go out, we sent somebody else out.
Okay.
And she had to write up a nice long report. And the entire DOE said, yep, it's that building that's
right.
doing it. So this is why you need to work with your customer and explain what you are doing and why you are doing it. So the idea behind our M&V efforts is that what we're trying to do is we want to allocate those risks, and we will also at the same time want to minimize the uncertainty in the savings estimates. You know, back in the day, our big challenge was pushing back on what we used to call stipulated savings that were just a bunch of made up numbers, because there was so much uncertainty and not enough measurements going in. The numbers could be anything. So we want the ESCOs to do some measurements to minimize the uncertainty and provide real information. So if we can measure more, that reduces the uncertainty and therefore the uncertainty risk associated with that. The problem is that measuring more is more effort, adds money to the project. So we're always trying to balance this M&V cost v reduced uncertainty. So how do we?
Because the customer doesn't want to pay more money.
Well, that's true. The customer doesn't want to pay more money because everybody seems to think that what the ESCO does is free. We know that's not the case. It all gets passed back to the customer one way or another. But we still need to do some, and we need to spend some modest amount of money.
Can I interrupt again?
Sure.
So you guys, what I want you to notice is that this is an evaluator. So this guy, Mark, spent a lot of the last few years evaluating ESPC M&V projects, isn't that right?
Yeah.
M&V reports.
IGA.
And he's someone who actually understands where you're coming from. I always thought, I guess coming from a fear mentality, that guys like him hated ESCOs and we're always there to poke holes in everything we do. What you'll find, I think, interesting in what he's saying, if you kind of listen between the lines, is he gets it and he understands that things go wrong and that sometimes you just have to do the best you can with it. And that's, as long as you're honest about things and tell what happens, what happened and what you did, and you try to really measure savings, he buys it. And that's what you might kind of hear from what he's talking.
Well, let me be more specific. I've shot back M&V plans. I said, you're oversampling. It drives your M&V cost up. Cut your sample size back.
Wow.
So how's that for a direct thing? Because I'm cognizant of M&V cost, and I don't feel that it's valuable to spend money on something that is not providing a lot of additional information.
That's great stuff.
So
good.
Okay. Next. All right. So this was a study we did, and when I say we, that's Satish Kumar and Paul Matthew, two statistical propeller heads at Lawrence Berkeley Lab. And we were just kind of looking at that. And some of these numbers are based on hypothetical projects, but the argument is that there's additional costs with these different measures, and these are old designations that are no longer relevant today. But the idea was that, what is the uncertainty in the savings versus the cost? And so we were just trying to play around with this, trying to figure out, well, if we spend more, how much do we actually collapse? And so maybe spending some money on M&V is better than spending no money on M&V. But again, it's a balancing act, and the optimum point really comes to where your comfort threshold is. But slide. Now, this is a study I actually did a few years back from a number of IGAs that had been awarded. And these are the first year M&V cost as a function of first year project savings. And I put a regression line in there with an R-squared of 0.14 to drive a point home that it's not a solid relationship between the two, but we can still derive some information. You'll notice I have 3 outliers on here. And these are points that are not your typical projects. For example, the one in the lower right was a big combined heat and power project. So here, we just have 3 measurements to make: natural gas going in, electricity coming out, hot water coming out. So 3 measurement points, not 3,000 measurement points. So a lot of savings, minimal measurements. So the M&V cost as a function of savings is very small. On the other hand, we have another one that's way high, and that's because it's an international location. It's in Central America, and they got to send, guys down to Central America to do their M&V effort. They got to get all this stuff through customs. Then they got to get it through the State Department security, which is even harder. Then they got to do the work and all of that. So a lot of that cost is not measurement cost, it's transport and logistics cost, but it's real. The benefit is that they're only going to spend that in year 1 as part of the first year performance report. And then they have some remote access capabilities that they can use to track in years 2 through N. And another project there was, I believe it was GSA Region 8 that covers, 6 states: Colorado, Nebraska, North and South Dakota, Wyoming, and Montana, for example. So now we've got sites all over the place. So even if we have remote access, we still have to kind of set foot on these sites and collect actual observations and check O&M logs, etc. But in general, ESPC projects come in roughly 4.5% of year 1 savings, with some exceptions, and we understand these. And this is not unreasonable. It doesn't prolong the simple payback and the project term very much. If you start getting upwards of 10% like these other projects, you're going to start changing the economics. So just something to be aware of. But these are all real ESPC projects awarded up to about 20, I think I did this in 2016.
This would have been interesting if you put percentage on the y-axis, right?
Yeah, I didn't want to do that. I wanted to, because I was drawing a model here and I wanted to show the relationship. Because now the slope is the percentage.
Yeah.
Okay, slide. All right. So what drives your M&V rigor? Why do some customers want a lot and some just don't really care? Well, every agency, every customer has their own cost benefit mechanics that they use internally. So some of them are risk averse, whereas others are willing to take a little bit more risk. Technical project risk. Lighting, yeah, we should be able to do that without a whole lot of project risk. Whereas PV might be perceived, especially if you have a microgrid, that might be considered a little bit more technically risky because of its complexity and to some extent its newness. So you start dabbling in battery storage systems, for example. Yeah, there's a little more technical risk, and people want to be reassured that those systems are working and doing what they're supposed to do. They may have requirements to report to other agencies or in their own internal bureaucracies. Maybe they want diagnostic information. Some are into due diligence or just obsessive compulsive disorder. If you've ever worked with AFCEC, you'll know exactly what I'm talking about. And then some of them want to see long-term savings persistence. So you really need to understand the customer and the project motivations. We did a study. When I say we, that's when I was working for the DOE. In 1999 or 2000, again, early projects. And we reviewed some of the early projects, and we're trying to understand, what M&V method was used, what was the M&V cost, and the reasons why they chose these particular pathways. And that was, we found, it was really the customer motivation that was the single largest identifier of how rigorous the M&V approach was. It wasn't the capital cost or the dollar savings. It had everything to do with what the customer wanted. Why this is a surprise, I'm not certain, but I think it bears reiterating because I don't think that's changed in 20 years. But as engineers, if we are, we tend to focus on the technical aspect of it, but oftentimes our M&V efforts are actually driven by subjective and possibly emotional factors as well. So know your customer. So slide. All right, M&V protocols, we know what these are, the guiding documents, and that should be the latest link to the FEMP M&V guidelines. All right, slide. If you need to read these definitions, you're probably in the wrong talk, but I put them in for completeness. Slide. But let's just consider the diagram. Just makes a little more sense. So we like option A and B because of retrofit isolation methods. If you look at the diagram and we do two measures, we put PV and we change the lighting, and we try and look at the meter, that meter consumption is affected not only by the things that we do, but also by the other things over which we have no control. And where we have an uncontrolled element to our project, that's a risk factor. So this is why we don't see a lot of C and D to some extent in ESPC projects. We do like A and B, and we also like it as evaluators for those very reasons, that we don't always trust the results of option C, even though some people swear by it, or that's the first thing they think of, or they want to be reassured that the savings are occurring in their meter. There's a lot of uncertainty that goes into that. All right, slide.
Well, we over here at Abraxas, we like option C, just so you know.
I'm not trying to dissuade anybody from using option C. I'm just saying I don't see a lot of it in the ESPC world. And so these are just some of the reasons to use some of the different methodologies. We don't have to go into. So I always argue simple measure, simple M&V. So low risk, low cost M&V, perfect for option A. Also, it does a nice job of allocating the risks, because option A being the key parameter measurement, we're going to measure what we're responsible for and not measure what we're not responsible for. If we can ignore interactive effects or somehow capture them explicitly, both option A and B can do that. But generally, option A doesn't always capture the performance measurement depending on what ECM you're implementing. And so this is why option B, if we take some kind of energy measurement every year, even if periodic, we can be reassured that something is working, over the next 20 years. On the other hand, if you have difficult to measure ECMs, like windows or new construction, then that almost forces us to do an option C or D approach, because we can't really measure the energy flow through a window very easily. And if we want to capture all the interactive effects between measures, again, option C does that very well, provided they're large enough that we can capture all of the savings in the first place. And the catch is that both options B and C generally capture some of those uncontrollable factors like the weather, and we might have to take some extra steps to compensate for that. Okay, slide. All right, this I just lifted out of the M&V guidelines, but this is just a formal thought process. Just says, okay, for each of these options, what are the benefits? What are the costs? What are the risks? What risks am I willing to accept? What costs am I willing to assume? And then that kind of guides your thinking as to the approach, over and above what I've already mentioned. All right, slide. Under FEMP 4.0, though, they've already come out and recommended particular M&V approaches for particular ECMs. I don't necessarily agree with 100% of these recommendations, but I didn't write 4.0, so it wasn't my opinion that mattered at the time. So if you're doing any of these, this is what they're going to guide you to, and it depends on who you're working with as to how rigorous your reviewer and your customer are going to adhere to these. If it were me and you had a reason for doing option B instead of option A on something, I'd say, sure. I'm not going to get too wound up about it. For example, on BAS or EMCS upgrades, building energy control systems, yeah,
That's crazy.
This is what it says. I mean, I'd have gone with B.
No, I
because
C.
Well, you would go C. Of course you'd go C. It's what you do. But I'm saying with option B, that system that's monitoring your energy using systems can also measure them. So it can serve dual purposes. So there's an argument, so yeah, depending on the situation, B or C might be more appropriate.
Crazy.
Like I said, I'm just telling you what they said. I'm not saying that I agree with this.
That is nuts. Okay.
All right.
All right.
Next slide. Okay, so now this comes down to the title of the talk. What do we look for? So we're the project facilitator and the engineer and the evaluator. We're looking out for the government's interest. We want to protect their interest first. That's what we do. And oftentimes I tell total strangers, oh, I look out for the taxpayer. And they go, oh, cool. That's great. So they love that. So what do we look for? Well, do we have a baseline that we trust? No matter what we're doing, has it been adequately established? Are you doing enough in the post-installation period during the first year? Are you doing enough during the next 23 years to satisfy everything? Do we believe the finances? Are the M&V costs reasonable? Or is it going to kill the project, or is it going to be scuttled entirely? And I have pushed back when I've seen numbers that I think are too high. And have the risks been equitably distributed? I don't want ESCOs taking risks that don't belong to them. That's just silly. Because it drives up the cost and it creates friction down the road. All right, slide. So, do we have an adequate baseline? Do you have your sample measurement size is reasonable? And this is one, and I teach statistics because people often get this wrong. Is I don't know how many times I've seen, oh, 80-20 equals 13. It's like, well, what's your default CV? What's a CV? Okay, take my class, and we'll discuss that. And then one of the things I rarely see, but I like to see, is once you've taken the measurements, what is your uncertainty? Because that's really what we're after. We're trying to drive down the uncertainty to acceptable levels. But one, we have to define what is acceptable, and two, figure out, well, did we meet that target? And again, that's something that is often given short shrift. I mean, I've seen one or two of the ESCOs get into this.
Are you going to show an equation for uncertainty?
No, I'm not. No equations, no math.
You're not talking fractional savings uncertainty.
No, we're not doing that. I'm just speaking in generalities. We're not, no equations.
So, but 80-20, that's uncertainty, right?
That's 80-20 is 20% uncertainty of the measurement with 80% confidence.
Right. Is that what you're saying?
That's what I'm saying, yeah,
okay.
Because that's what people know about how to develop a sample size.
Okay.
If your default coefficient of variation is 0.5, which is appropriate for measuring lighting operating hours, that'll give you a sample size of 13. If your default coefficient is 0.25, which might be more appropriate for fixture power measurements, then it goes with the square of that. So your sample size going down by a factor 2 goes down by a factor 4. This is about 3 or 4.
3 or 4.
Oh, sample size, n equals 3 or 4 for a sample CV of 0.25. And so the argument here is that we can establish reasonable sample sizes if we have a better estimate of our default coefficient of variation. I don't want to go into equations. I don't want to go into statistics. So I'm just going to put that discussion aside.
But before you do, some of you guys know what he's talking about, this whole sampling stuff. It's all in FEMP guidelines. Is it also in the IPMVP? Do they have that sampling section in there?
Actually, in the IPMVP, what you want to get is not the core concepts, but the new uncertainty guide. And you may have to be an EVO subscriber to download that.
Yeah. And anyway, so, but is there somewhere published where it says, look, if you're going to do lighting fixtures, the CV should be this, your initial CV. Your initial CV for package units should be this. Do you have, is that published anywhere?
Actually, 4.0 provides some guidance in that area.
What 4.0?
I'm sorry, FEMP M&V guidelines version 4.0
It does,
in the appendices.
Good.
They actually have in the back, not only recommendations, but recommended default values.
That's nice.
And things like that.
That's good.
So,
thank you.
But you still have to pick and choose. So it does require some knowledge of statistics to get this right. And as I was explaining to John, I've pushed back when I think the sample size is too large, because taking lighting fixture power measurements can be an expensive proposition, and I don't want people to overdo it if they don't have to. All right, slide. And likewise, you know, the post-installation, are you doing your commissioning, your post-installation measurements, again, comes back to the sample size, target uncertainty measurements. And are you measuring the right thing? You know, sometimes we want to measure everything, but not everything adds value, even though it might seem like it does. Do the measurements include usage factors? Are you implicitly or explicitly capturing the weather effects, and do they need to be considered? So if you measure, you know, chiller demand on a 90-degree day, and then you put your, or we'll call it a rooftop unit, and you change out your rooftop unit, and a couple of months have gone by, and now it's 60 degrees, and you take a KW measurement, yeah, the KW is going to be less because you haven't corrected for weather. So there could be some effects in that need to be considered. So that's, you know, when are these measurements going to be conducted? Not just on a calendar, but as part of a season. Are you going to conduct your boiler efficiency measurements in July and your chiller performance in January? Because both of those would be silly. And again, I pushed back on some of those things. It's okay to get project acceptance and then do that measurement sometime during the first year. So a lot of times I've seen that, you know, construction is completed in August, but the boilers aren't turned on until October. And then we'll do the efficiency measurements then and report the values. All right, slide. And the performance period just kind of echoes the same thing. And here we often get away with less measurements. Most of our M&V activities do occur, you know, during the performance, post-installation, and during the first year. So again, same thing. So I look at all these things and say, am I going to be assured that the government is going to see performance, and is that going to be sustained during the performance period? And what other information do we have apart from equipment measurements? Do we need to include usage factors like number of patients in a VA hospital, for example? Okay, slide. Financial parameters. We do look at the economics and make sure it makes sense. But there's always been a discussion about utility rates and how we deal with escalation. We don't normally use static utility rates, so we use escalation rates. So how do we determine these escalation rates? I mean, you can try and do all of your own projections. I don't recommend it for the very simple reason is that the government wants everybody to calculate the escalation the same way. Not that EERC is a better predictive tool than anything else you can do. It can be just as wrong as anything else.
What's ERC?
It's the energy rate calculator.
Oh, okay.
Energy escalation rate calculator.
Okay.
So I gave you the link where you can download that. Runs on both Mac and PC. Needs to be updated every year. But the idea is that, you know, how do we predict what the energy escalation rate is for our project? So we download this and we use that because, of course, predictions are hard, especially about the future. Just to digress on another story, that project in Central America I was mentioning, I think that we were putting that together around 2013, 2014, I forget the exact time period. But that country derives all of its electricity from burning oil. And the price of oil at the time had been going up. And when we were putting this project together was well over $100 a barrel. And we said, okay, how do we determine this? Because now EERC doesn't work for states outside the continental United States. So I worked with my rep at the State Department, and I got dragged Phil Coleman at Lawrence Berkeley into this as well. And we looked at the 60-year historical escalation rate for petroleum. And we were in the 5-6% range. And so that's what we ended up using. And then oil went to $40 a barrel.
Yeah,
so,
right. I was wondering, why didn't you just use the, why couldn't you, whatever.
Well, because we didn't know it was going to go to $40 a barrel.
And then they had to write a contract.
Yeah, so, but the idea is that even if EERC is wrong, that's what the government is telling you to use. And if you have a reason not to use it, like I'm working in Korea, okay, then that makes sense. Now you're on your own.
Or a school district or a hospital.
Yeah, I mean, you're right. This is for federal projects.
Yeah.
Thank you, John. This is for federal projects. Yeah. For other projects, you're free to use it or not.
Yeah, I mean,
but,
I was looking at our average inflation rate over the last several years. It's only like 2.5%.
Yeah, so we use 2.2 as the default inflation rate.
Yeah.
And so sometimes on the natural gas, you'll actually see a negative inflation rate. Yeah. Slide. Okay. Are the M&V costs reasonable? In other words, are you committing enough resources? And I'll flag it if I think it's too much or too little. both directions. Well, what I don't want to do is burden a project. If that number is above 10%, that's a real problem because that will affect the project economics.
But can you give a range for
something
that's not just a lighting job, but
yeah, well, previously when I looked at the ESPC projects, now they were larger projects where you could absorb some of the fixed costs, but they were in the 4 to 5% range
4 to 5
as being reasonable, and that's a lot of option A and a lot of measurements and site visits during that time.
Okay.
So there, and as well as report writing. We know, we joke that the year 2 report looks an awful lot like the year 1 report, a lot of copy and paste going on.
Yeah.
That's fine. So that cuts down some of the costs and the effort in future years. And this is some of the reason that the year 1 report is so
So the
important.
clients hate that.
What?
That the reports look the same every year. Some of them, they say like, oh, the ESCO, they didn't do anything. They just keep doing the same report every year.
Well,
but you guys understand, at least evaluators understand.
The mathematics aren't going to change.
That's right.
The only thing that changes are the measured values. So if I'm doing an option A on a boiler and I'm measuring the combustion efficiency every year, all I really want to see is that efficiency measurement. What date was it taken? What were the results? Are they different from previous years? Do I need to do anything?
Yeah.
And then, show me that the guarantee is met based on that.
No, it's good that you guys understand that the reports, they're going to look kind of similar every year.
Yeah, I would hope they would look similar. All right, slide. Okay. So lastly, and I do look at this, have we allocated all those risks equally? So we want to put the usage risk back on the customer where it always was. Same with the financial, and that includes, the utility rate escalation and the rate risk, because that's always a problem, but generally they have that anyway. But for the ESCO, I do want ESCOs to be responsible for the performance aspect and how they're going to maintain it and how they're going to prove it during the performance period. All right, slide. So in short, we look for defining the baseline because that is going to address the questions. I've been involved in a lot of discussions and disputes where we try and go back and we look at the baseline and it's like, what is this? There's insufficient information. I can't really tell whether there's any savings or not because I don't have enough information to see what the baseline looks like. It happens. And this is, how we learn and we've gotten smarter.
Wait, I want to interrupt. How did that project conclude?
I think that, okay, I was thinking of one particular project where it was basically a lighting only project. And they went in, did an inventory of the lighting fixtures, and this was a long time ago. So I think they found a couple lighting fixtures were F40 T12 magnetic ballast, and they made the assumption that all of the fixtures were F40 T12 magnetic ballast. And the problem was that there were a large number of F34.
Right.
And that dragged down the power consumption. And so when you look at the calculated savings under option A with few to no measurements and a poor inventory of what was removed, and you compared it to the utility bills, there was a huge disconnect.
And how did this get resolved?
The contract was the contract. So they said, look, you agreed to it. This is what it is. This is what it is. So the customer was a little unhappy, but they could have also been doing things to increase their energy consumption on the other side. But I still think that the ESCO got lucky on that one, that they said, this is what we said we were going to do. And even though I felt that their inventory was inadequate because they couldn't really document the mix of F34 and F40s, they didn't have enough measurements, they didn't have enough inventory, identification. When you pull the tubes out, run through the crusher, you can't go back and figure out what it was. Good. So
keep going. Sorry.
And that's okay. And then the post-installation, the performance period has to be there. And coming back to the O&M, there's one project where I've done, I've reviewed the post-installation reports for years 2 through 5, the performance period reports. And the O&M responsibility is owned by the agency. And there's been a failed VFD for 3 years running they assumed responsibility for it. They haven't replaced it yet because they haven't gotten around to it. They don't have the money. And the ESCO says, you said you were going to replace this. You haven't. We're claiming the savings as if you had. And because you haven't, here's the savings that you're not realizing because you haven't replaced those.
That's fair, right?
That's the way the M&V plan was written.
Yep.
And that's the point, is that by identifying how they're going to be addressed, then it avoids the conflict. clearly falls on the agency to do this. And they did, they could have gone the other way. They could have accepted higher O&M costs and more R&R costs. And then the ESCO would have fallen on the ESCO. That's in that negotiated point I was talking about.
But the fact that they actually said, this is your risk, that was really important. If
Right.
they wouldn't have done that, then it would have just been finger pointing.
Then it would have been finger pointing. Yeah, exactly.
Huh.
So this is why we try and define who's responsible for fixing what. And you'll see that when and I didn't even bring this up, in the federal world, we use something called the risk responsibility matrix. And that actually drives a lot of how your M&V plan looks like, because that's where those O&M and R&R risks and responsibilities are defined. I do look at costs are reasonable, and I look at both directions. I'll sometimes push back and say, you're not spending enough on M&V, and people are kind of puzzled sometimes to hear me say that. But if I don't feel that you're doing enough, that you're not taking sufficient measurements, if you're not conducting enough site inspections, that you're not really doing the customer any favor, or yourself for that matter. Spend a little more, the project can support it, don't cheap out. So I try and look at that, and I have pushed back on that. And then everything comes down to, are we equitably allocating and distributing all those risks that we've identified? So with that, let's open it up to questions and chat and discussions.
I have good questions right there.
Let me see if we have any questions so far.
Oh, you do.
Okay. I shouldn't mention too many names, but okay. So I have a question from
Robert
Art.
Lemire.
Maintain some confidentiality here.
I didn't say anything.
I mean, RJL, I know him. I know where he used to work. So yes, AFCEC is very pro option C. And I would urge you to search out the, they call it the ESPC playbook in the Air Force. It's a public domain document. And what the Air Force says is that they want measured savings with a preference for option C. And they want 67 to 70% of the savings verified through measurements, preferably option C. They'll take B, they'll grumble about it, but they'll do C. They don't care what FEMP's opinion is. The Air Force marches to its own band. So they're gonna do that, they always have, and presumably they always will. So if you're involved with AFCEC, yeah, you're gonna get, you're gonna learn a lot about option C and to some extent option B.
He already knows option C.
I but other people don't. So yeah, AFCEC is, the Air Force is very pro option C, very pro measurement. You might be able to persuade them to use option B.
But you really don't want to. Okay, what's the next question?
All right, remember. So this person, PC, John, can we use metrics on option B? I'm gonna let you take that one.
I don't know how to take that, you take that. I mean, yeah, I guess so. So people might want to use it just to do regressions, but
Yeah.
you can do that in Excel, right?
You could, but the benefit possibly, let me see. Okay, we'll come back to that. We can use metrics. Actually, personally, I would tell you to use option C, because under option B, you're rarely using a regression model on 12 data points. You might be pulling BAS trend data,
Yeah, they're
and
taking
you'll have
a lot of
hundreds and thousands of data points. So can your program option C handle that?
Well, option C can, yeah.
Okay.
Yeah, no, you can. And the other thing is, I guess, the programs can handle 5 variables. Well, 2 of them are weather. So if you don't want weather, 3 variables. And so, multivariable regressions might be a little harder in Excel. I don't know. I haven't tried multivariable. I've heard of people doing it, but I don't know.
Okay. Well, maybe you should learn how to do that. You can give a webinar on how to do that.
I don't want to. It's in metrics. It's in option C. It's easy.
All right. And the same person, PC, reminded me that Bonneville Power Administration has a whole library of statistical references that are free, but I don't have the web link handy at the moment. But if you search for BPA, for Bonneville Power Administration, and we'll call it sampling guide, but they have guides on sampling, on regression modeling, and M&V in general. And this person was reminding me to say that because I wrote the old sampling guide, although I realize it has been updated recently. And with respect to option C, I also wrote a paper that's going to be distributed in the EVO newsletter coming out next week, that discusses some of the uncertainty aspects of using option C and the savings uncertainty. Again, these are kind of high-end statistical things, but this is what John and I do is, we spend our time playing with our slide rules, worrying about statistical uncertainty in our savings estimates.
So it was kind of, correct me, because you watched my seminar, my webinar on. So I don't know if you remember the statistics webinar I did on CVRMSC and R squared and all that. It's kind of some of that, and then there's more, right? What's the rest of in the article? So you talked about CVRMSC, you talked about R squared and why it's not really the best statistic to use, but what else is in there? In paper.
In mine?
Yeah.
No, that was the gist of it.
Oh, okay.
And the gist of it was don't get wrapped around the axle about R squared.
No.
Look at your savings uncertainty, because that's really what we're trying to minimize.
You mean the CVRMSC?
CVRMSC, which is directly
not
related
the fractional savings uncertainty. That's Bill current. Well, Bill actually has something new now.
They're linked.
Yeah. Okay.
Anyway, again, I don't want to bore you with all the statistics. That's not what this is about.
Robert just said it. All right. So what's our next question?
Yeah,
a whole bunch. We better
I
get
thought we
to
had 3.
No.
Okay. So, all right. Okay, this is a little involved. Let me see if I can get through here. Some ESCOs propose to use option B and use trend data, recalculate the savings for that performance year, while others propose option B to analyze the performance of the ECM.
Keep going. Read the rest.
Okay. What do you think is the best approach to use option B, or it depends on the agreement between the ESCO and the customer? I think the short answer is it depends on the agreement between the ESCO and the customer, but let me explain. If you have a measured energy input to a system, be it a chiller or an air handler, that's varying over time with weather conditions, technically one method is to take that measured energy use and deduct that from the baseline. That gives you your savings under actual performance year conditions every year, and that number is going to fluctuate every year, up and down. And in some cases, what happens if there's a saving shortfall because the weather is contributing to that. On the other hand, some ESCOs will say, we'll measure the energy consumption every year, and we'll show that the system is doing what it's supposed to do, it's providing savings, and on a particular day or so, it's doing exactly what it's supposed to do. And they say, if that works, we will make the assumption that the savings target has been met, independent of what the weather does 364 days a year. That is an acceptable approach. The benefit there is that it is removing the weather risk from the ESCO and putting it back on the customer where it belongs. But that has to be a negotiated point, and it has to be spelled out in the M&V plan as to how to do it. But both of those are acceptable approaches. But again, it comes down to what's acceptable to you and what's acceptable to your customer.
Before you answer another question, let me ask one real quick.
Yeah.
So sometimes, let's say you're doing an option B for a chiller retrofit. Okay, and so you're monitoring the chiller, let's say for a full year, full year of trend data, and your flow meter breaks for 2 months.
Yeah.
Or, or you're missing 2 or 3 temperature sensors you need, or something like that.
Right.
What do you propose they do?
Well, depends on when it happens, but one methodology is we calculate the savings for the period in which we have savings and see if we can then project what those savings should have been, assuming that equipment works. And there's a couple of different ways to do that. So if we can make a performance map of the system based on the information we do have, we can kind of fill in that information.
That's right.
And in fact, we're doing something similar to that right now at a very large project where we have 5 3,000-ton chillers. I always get them. 7 3,000-ton chillers. Yeah. So we're talking 20,000 tons of cooling, district cooling.
Is that here?
Here.
Yeah.
Riyadh. Yeah. Well.
Yeah. So,
and what we're trying to do though is trying to use normalized savings, and this is the approach that we're trying to do with option B. Is we want to measure a performance map of the chiller plant, or more correctly, all of the pieces of the chiller plant, and then use that to determine what the savings would be under a normalized set of conditions.
TMY.
So that TMY and also the load profile. So that if the facility changes the load profile, it doesn't decrease the savings so long as the performance metric is met.
So in my past, this is when I knew a lot less about M&V, but when I first was doing these option B projects and you're metering all this stuff. I mean, those of us who've been around a long time realize stuff never works right, and you just don't get all the data. You can go and check and everything looks good. You put it down, you checked a week later, everything's good, and then all of a sudden it's not good, and you didn't notice for a month or two, and you don't have all the data. That happens, and what's good is it doesn't mean that you totally screwed up. It means that you just gotta acknowledge this happened, and therefore this is what we're gonna do, and you write that in your M&V report. This is what happened, this is what we did, and here's the new savings number. Does that sound right?
That sounds exactly right, and that is always the advice I give to the engineers I've overseen or people writing these reports. Tell the story.
Yeah.
It doesn't have to be an exciting story. I don't need plot development.
I do.
Just the facts. What happened? How did you address it? Does it make sense? Here's my justification. Here's the results. Because that's transparency.
Mm-hmm.
It's not, oh, I just made up this number. It's, we had a problem. We created a model. We plugged the model into the information we had. Here's the result. We plugged it into that 2 months.
Yeah.
Oh, okay. I get it. Now it makes sense.
Yeah.
And if I have questions, they're going to be rather small, minor questions, not why is there a 2-month gap?
Yeah, you guys screwed it all up. This isn't right.
Yeah, we don't want to do that.
No savings for 2 months.
No, just be upfront, because we know that stuff happens, and Murphy is very much alive and well.
In the M&V world, yes. All right, what else? Do you got more questions?
I'm scrolling through, but AD gave us the last one so far.
Oh, that was the last one. Oh, okay.
All right.
All right, so we're doing good on time.
All right, so slide, because you have some email addresses.
Oh yeah,
Tyler had put in a few more. So just a quick plug for my own services, because most of you are familiar with the practice. But for example, if you are an ESCO, some of the things I might be able to help you with would be M&V plan development, or at least a QA/QC review before you send it out the door. And I look at this with the same eye, covering all the things we just discussed. I can also do the same thing, on your reports. And I've helped others do that as well before the reports go out the door. Because it's hard to QA/QC your own work. You just don't see those things that are glaringly obvious to everybody else. I just had something where I caught a mistake. And I can also do the data analysis and the economic evaluation, and I'm available to do customized workshops of any duration of your choosing, either at your location or via webinar. All right.
Mark, it looks like we got one question in here. It's kind of a long one from RK. I don't know if you saw that last one.
Just came in. Okay. RK writes, year 4 of the performance period, the customer does not understand why inspections for option A do not include any measurement verification and are visual inspections only. Most of the O&M and R&R is covered under our subs. Customers now pushing for more measurements in the performance period. How often do you recommend taking toilet, faucet, and light measurements? A legitimate question, because this goes back to cost. When you say, let me be clear, under ESPC, we rarely advocate for taking lighting fixture power measurements during the performance period. FEMP guidelines 4.0 recommend and encourage lumen lux measurements, lighting fixture level measurements, to make sure that your lumen depreciation has not sufficiently degraded, but it's not a requirement, it's encouraged. And the same thing with toilet and faucet measurements, because if you put in a low flow fixture, we again make the perhaps somewhat faulty assumption that these things will work perfectly for the next 20 years.
So, but wait, but there's a post retrofit report where they actually do the measurement.
Yes, the year 1, but now we're in year 4.
Yeah.
And this is when I was talking about annual performance period. So in the year 1, or actually during the performance period, there's little to no value being added to take fixture power measurements. And I rarely, and I always say, we don't need to do that.
No.
Do the lights work? I do encourage lighting level measurements. And I have tried to encourage water consumption measurements on a sampled basis, but maybe not even every year.
Of toilets.
Of toilets, yeah, because it's kind of a messy proposition. You pumping the water out of the bowl and measuring it.
It's just labor. It
It's
doesn't do any
it's
good.
labor. I mean, we can measure 1.3 gallons, but it's messy and but not hard. So, but maybe the thing to do is do it once every 3 years on a sample, because with toilet flushometers, they have parts and they wear out, and the volumes can creep up. The flush volumes can creep up, so it can change. I mean, ultimately, you can always look back on the M&V plan and say, well, this is what we agreed to, and I don't know who reviewed this and signed off on it, but
This is the contract.
this is the contract. On the other hand, if you get a lot of pushback to split the difference, do a handful of toilet measurements and inspections, but not. I wouldn't even suggest maybe every other year. So, yeah. Again, we're still learning in this field as to what should be measured and what actually is measured.
Well, but then there's also just personalities. I mean, it doesn't have to be logical. Sometimes you have to do dumb things to keep your customer from, coming at you.
But the point is that the customer, in this case, I mean, I don't want to say the customer is always right, but the customer is concerned and they want to see some diligence on a performance contract, that there is actual performance.
Yeah.
And if it takes measuring a handful of toilets every other year,
Do it. Yeah.
It's the delta cost probably isn't outrageously high, even if you didn't do it. And the same with lighting, lighting level measurements. That's an easy one. You just walk around with your light meter. And if you do it during the day, it'll probably be higher because of daylight versus doing it at night. I was just having that discussion with the ESCO. Oh yeah, we got 700 lux, but all the windows were, we were near the windows. Like, did you turn the lights on and off and take the difference? Oh no, we didn't do that. It's okay. We're going to teach how to do lighting power measurements.
All right, so our time's about up. Tyler, go ahead. What else you got?
That's it. Thanks for showing up, guys, and we'll see you next month.
Shukran and masalama.
That's right, Masalema.